Okay, so we are continuing in 5.1, ready, set, go. It's 17 and 18. So the goes basically mean it's preparing you for what's coming next. And so this, you will see some of these kinds of things in a couple lessons. Okay, so it says determine whether or not the quadrilateral task is a rhombus. Show your work to justify the defining properties of a rhombus. Okay, do you all remember what a rhombus is? What is the key aspect of a rhombus? If I said what is a rhombus, you should say this, and it's very short. Shoot, someone is putting stuff in the chat. Oh, here. No, I don't know. My chat is not parallel sides. So parallel sides is the defining characteristic that it's a parallelogram. So technically, a rhombus is a parallelogram, or every rhombus is a parallelogram, right? But it's not only that. There's another part about a rhombus that you need to remember. What else? Does anybody remember this? It's okay to be like, no. Okay, so the defining part for a rhombus is that all the sides are congruent. So yes, you can prove that all the sides are parallel, but more so you want to prove that it's all four sides are congruent. Okay, it's a quadrilateral who all four sides are congruent. So I can't, let me think. Would I want to prove that they're parallel first? Okay, I'm just going to go with parallel first just to be safe and so that you guys can see that too, because you haven't looked at this in a long time. So just as a reminder, if I wanted to prove parallel lines on a coordinate grid, relatively easy. These two are obviously parallel. SK is parallel to AT, right? These two are parallel because they are both horizontal, right? These are both sitting on horizontal. These two are parallel, and I'm putting in the parallel line marks for that. These two are parallel because why? Why can I prove that these two are parallel? Anybody remember why? So when I say the word parallel, I want you to think same slope. Same slope. So do these two lines have the same slope? And you're like, yes. Because look, it goes up 3, right 4. It goes up 3, right 4. Therefore, these two lines are parallel. So I would write something, if I was doing a proof, I would say AS is parallel to TK because they have the same slope. Okay. Because they gave it to me on a coordinate grid, they made it a lot easier for me to prove that they were parallel. Okay. Okay. So in proving that they're congruent, these sides are congruent. I would have to prove that this side is equal to this side is equal to this side is equal to this side. In reality, because I just proved that this is a parallelogram, right? A parallelogram's opposite sides are automatically congruent. That's the gift of parallelograms, right? There's a bunch of properties that you get. So I'll name a couple of them. The opposite sides are congruent. Opposite sides are parallel. Opposite angles, meaning angle A and angle K, are congruent. Angle T and angle S are congruent. If you don't remember all these, don't worry about it. I'm just going to pluck off the stuff that I need, and then I'm going to move on. So because I proved that I have both pairs of opposite sides being parallel, therefore it's a parallelogram. Okay. And because it's a parallelogram, I already know that AT is congruent to SK. And AS is congruent to TK. So in reality, I just need to prove that AT is congruent to either AS or TK, and then I'm done. Okay. So I'm going to count how long this side is. So I count 1, 2, 3, 4, 5. And I'm like, that's 5. And this is 5 up here. And then now I just need to learn how long this side is, and then I'm done. So whenever you're trying to find how long a side or length is, and it's not along the horizontal or the vertical like axes where you can't count it, your brain should immediately jump to the Pythagorean theorem. Okay, so here's my little triangle here. I'll dot it out so you guys can see which triangle I'm talking about. It is a right triangle. So then, oh, it's right here. It's going to show up any day now. Hold on a second. Nope, it's not. It's mad at me. Okay. It's this triangle right here. You guys all see this one? Okay. So how long is this side? Oh, there goes the triangle. How long is this side right here? How long is this side of the triangle? You're like 1, 2, 3. Yeah, exactly. It's 3. And then how long is this side? And you're like, oh, it's 4. So that means I need to find this side. So the Pythagorean theorem tells me that this squared plus this squared will give me that squared, the hypotenuse. So I go 3 squared plus 4 squared, and I'm hoping that it'll be 5, but who knows? Let's see, 9 plus 16, that's 25, equals c squared. So therefore c equals to 5. Yay! And if you look, that's the same exact triangle right here. And this is 5 as well. So there, I proved that it was a parallelogram. I proved that it was a parallelogram. Okay. So that's that. I proved that it was a rhombus. My bad. I proved that it was a rhombus. Ooh, no, don't do that. Oh, I didn't paste this down. Give me a second. Okay. So the next thing that I want to do is number 18, which is the question that you guys actually asked. It says, consider the quadrilateral task in problem 17. Provide an argument that will either prove or disprove that TS is perpendicular to KA. TS is perpendicular to KA. So I'm going to move all of this stuff that I drew on here, so I just have more room to write on here. So they're asking, can you prove that AK is perpendicular here? Sorry, that's not a perfect drawing. Imagine that was a better diagonal. They want to know, is this perpendicular? That's the question. Okay. Okay. So the way I would prove that it is perpendicular, let's see. Which way do I want to go? There's actually a lot of different ways. So since we already proved that these guys were parallel and congruent and all that other stuff, I'm just going to make my markings again. So this is congruent to this. This is congruent to this. And all 4 of them are congruent, right? We already know that. Okay. The other thing that we know is that they're parallel. So I know that this, so let's use, I don't know, a different color. I know that this is parallel to this, and this is parallel to this, right? Okay, so what will so I think I'm going to use triangles are congruent, because that's just a way that makes the most sense. And you should see a bunch of triangles in here. You should see a lot of little triangles in here. And it doesn't matter which 2 triangles that you prove to be congruent. They will prove to be the same. Okay, so I'm going to prove this triangle here, and I'm going to label this N. I don't know. I'm going to label that point in the inside there N. So just so I can talk about. So I'm going to prove that triangle ANT is congruent to triangle ANS. Do you remember the ways that you can prove triangles are congruent? There's 4 plus 1, 5. Do you guys remember how to prove triangles are congruent? Do you remember how to prove triangles are congruent? If I say one of them, you'll be like, oh yeah, I know all these. Yes? No? Maybe? Okay. I don't know if you're... Okay, so here's how to prove triangles are congruent. Ready? So we have SSS, SAS, ASA, AAS, HL. You guys remember these? Okay. Okay. I will tell you the bad ones. So if you want to, like, Miss Johnson, which ones can't we use? So I'll put them over here in red. AAA and ASS are not ways to prove triangles are congruent. Miss Johnson, you wrote a bad word. Yes, But now you will remember. Yay. Okay. So ASS is supposedly a bad word. So ASS is a bad word and you can't use it to prove triangles are congruent. Maybe that's why it's bad. Do you ever think about that? Yeah. AAA, AAA, and here where we live, it's a really good car helping company. Like if you get stuck, if you lock your keys in the car, they will help you. But you know what they won't help you with? Proving triangles are congruent. Okay, so these are bad. They do not help you prove triangles are congruent. AAA actually helps you prove something else. So we'll talk about him later. But right now, these are the ones we're going to focus on. So you're going to look all through here and try to prove one of these. So HL refers to hypotenuse leg. If your leg is congruent and your hypotenuse is congruent in a right triangle to another hypotenuse and leg, then those two are congruent, right? Those two triangles are congruent. I have a hypotenuse, supposedly, but we actually don't know this is a right triangle, so we can't use this one. So you aren't going to be used. No. Okay, and then I say, okay, well, looking here, I have this side, but I don't know about this side or this side or this. I don't know if those sides are congruent. So probably not going to be side, side, side. Miss Johnson, I don't see any angles. I don't see any angles. And that's kind of true, except for I can remind you of a couple of theorems that you know. So one of the theorems that you guys know has to do with parallel lines. And then because you have parallel lines cut by a transversal, you get all of these angles. But I will tell you that I want to use triangle ANT and ANS because those are the ones that we're doing. So if you look at those two triangles, neither one of those has a pair of parallel lines. Like, you know what I'm saying? It's this one and this one, but this one is not touching my triangle. So I don't care about that. And same with this one, it's parallel to this one, but he's not touching this, so I don't care. So I'm not going to go with parallel lines, but I do see this. Okay, does everybody see triangle AST? Does everybody see triangle AST? Does everybody see triangle AST? Yeah. So if you look at triangle AST, right? If you look at triangle AST, you see that the triangle is a isosceles triangle. So an isosceles triangle just means that two sides are congruent of a triangle. And in an isosceles triangle, because you have two sides congruent in a triangle, then the angles opposite those are congruent. So I'm going to draw a different picture of this just so you can see what I'm talking about. So the isosceles triangle theorem goes like this. I'll draw it in black. Because these two sides are congruent, the angles opposite of those sides are congruent. This is the isosceles triangle theorem. I'll say it again. If you have two sides congruent in a triangle, then the angles opposite of those sides are congruent. Okay, in the same triangle. So what are you saying over here, Miss Johnson? I'm saying this. This is congruent to this. So remember these little arc marks, they mean the triangle is congruent. Okay, Miss Johnson, we have an angle and we have a side. I'm so excited. Now what? Okay, so if you're looking at triangle ANT and ANS, I have an angle and a side. So far, all of these could possibly be it. And then someone says, hey, Ms. Johnson, isn't AN congruent to itself? And I say, yes, that's a great idea. So let me change colors. Yes, they're congruent. Now notice I use two tick marks here. Oh, it hasn't come up yet, but I put two tick marks here to denote that it's different. It is not congruent to AS. So AN is congruent to this, and you're like, Miss Johnson, I have two sides in an angle. It must be SAS, except for it's got to go in this order. It's got to go S, then A, then S. What does that mean? So here's my side. Hey, buddy, I need you to sync. Oh, that's not good. So it's still not there. So here's my side. Here's my angle. So it would have to be this side, which it's not. Oh, there it is. There it is right there. Okay. So there goes that. Let's see. Oh, I just thought of the other way. The other thing that you got from the fact that it was a parallelogram, remember we proved that it was a parallelogram, is that the diagonals bisect each other. No, the diagonals, yeah, actually the diagonals bisect each other, and the diagonals bisect the angles. So that means that this is congruent to this. And it means that, shoot, I need another color. This is congruent to this. Okay, that side is congruent to this side, all from the fact that it's a parallelogram. So there you go. You have side, side, side. You can even do side, angle, side. You can now do angle, side, angle. Like all of these actually work for this. So the fact that it's a parallelogram gave us all of those facts. So now we can prove, because these two triangles are congruent, right? Because those two triangles are congruent, I can now say that these two angles are congruent. And if you have a line and these two angles, oh, you can't see it because it's not in there, but these two angles right here, this angle and this angle here, they're congruent. And because those two are congruent, the only way that you can have congruent angles as a linear pair is if both of them are 90 degrees. So if that's true, then that means that these two lines are perpendicular. So yes, you proved it. Hey, Ms. Johnson, are we going to do proofs? Yes. Ms. Johnson, how much of this stuff am I supposed to remember? Technically, all of it. But don't worry, I don't throw you into the, into the deep end and say, okay, go swim. We will review this so that you'll feel really, really comfortable with it. All right.